Here we go with the first of several examples solving a quadratic equation using the quadratic formula. So our first example, we've got x squared plus 12x plus 35 is equal to 0. And that is already in standard form. So what we need to do, since it's already in standard form, is identify what A, B, and C are, comparing it to the general version of the standard form of a quadratic equation. We don't have a coefficient written for x squared, so that's a 1. By the way, in the standard form of a quadratic equation, this is something that's already been talked about, but a cannot be 0. If it was 0, that would mean you don't have an x squared term at all. It wouldn't be a quadratic equation. So, a is 1, b is 12, and c is 35. We're going to plug that in. B is 12, so negative b is negative 12. Underneath the square root, we've got 12 squared minus 4 times, we already said a was 1, and c is 35. That's all over 2 times a. 2 times 1 then. Now I did say we need to concentrate on the arithmetic that's under the square root first, but I did already handle the changing of the sign of b to get negative b, and also it doesn't hurt anything if we figure out what 2 times a is, the fact that that is 2. But most of our work is going to need to be in figuring out what's under that square root. We've got squaring followed by multiplication followed by subtraction. It would be okay to do the squaring, since that is just a special case of multiplication anyway, and at the same time 4 times 1 times 35. We've got a minus sign here. There's no negatives for what a and c are, so that's still going to be minus. And 4 times 1 is 4. 4 times 35 is 140. So bringing that up here, negative 12 plus or minus, we already know the denominator is 2. Square root of 144 minus 140. 144 minus 140 is 4. And that's a perfect square. So when you've got a perfect square there, just go ahead and take that square root. Because we've completely gotten rid of the square root, split that up into the two cases. Negative 12 minus 2 over 2, and I'm going to simplify that. Then we'll handle the addition case. It's going to be negative 14 over 2 equals negative 7. And in the addition case, negative 12 plus 2 all over 2. Again, we've got to do the addition here before we do that dividing. Negative 10 over 2 is negative 5. The fact that we completely got rid of square roots suggests to me that we would have been able to solve this equation by factoring. I want you to notice something that I'll come back to later. 4, number 1, it's positive. So that part that was under the square root, it's positive. And we got real answers. Also the fact that it was a perfect square, positive and a perfect square. That's leading to getting us rational answers.